So now we are going to learn the Thomson's atomic model. The rough concept of the Thomson atomic model we have already studied. Now we are going to study it in detail. If the short note comes, then you are going to draw the diagram or the figure for one mark. Okay, label the diagram properly, such as positively charged cloud is there, then seeds are there, then the radius of the that model is given by 10 to the power minus 10 meter. Okay, negatively charged electrons, everything must be labeled properly. Okay, so what is the model? Let us see. Okay, what does this Thomson was trying to say? According to his observation, we will see what he has observed. Okay, so okay, so first he was studying an atom. So he observed that atom is nothing but a positively charged sphere. So this is the sphere. Yes. Why we are using the word sphere here? Why I am not saying it as a circle or a ring? Okay. Uh, Round is there. Yeah, this is not completely 360-degree or completely round. Yes, I tried to draw over here. Okay, this is not the one dimension processor. This is completely a solid sphere, means three dimension is going to consider over here. Okay, so we are using the word sphere here. We are not saying if anyone will come and say, ma'am, this is the ring, you can't call it as a ring. This is the circumference of the circle. Yes, this is the circumference of the circle, but the Thomson was calling it as a sphere, means three dimensional space is there. Okay, so, according to his observation, he said that this is the positively charged sphere. Means what? Here, positively charged one cloud is there. Okay, this cloud is positively charged. Okay, and inside the radius is considered as a 10 to the power minus 10 meter. Okay, next is these are the electrons which are negatively charged. So, as he was the first person to observe the atom, so he tried to give us the thing which we know. Everyone knows what is how does the watermelon looks, what is the shape of the watermelons, and how are the seeds embedded inside the watermelon. Okay, so in order to understand easily, he has used the concept, or he gave the example which is analogous to his atom or the observation. Okay, so he says that these are the negative charge particles which acts like a plums in the pudding. So this model is also known as the plum pudding model. Okay, so there is no need of confusion uh, that if the question is asked Thomson's model or plum pudding model, you are going to use the concept of Thomson model only. Okay, because Thomson model and plum pudding model are one and the same. Okay, so next is what he was trying to say again in this observation, that this positively charged is uniformly distributed over the entire sphere. Okay, this positive charge was not uh, the density of this cloud was not less or more in the any part of the sphere. Okay, means to the entire sphere it was uniformly distributed. This positive charge was uniformly distributed uh, entirely in the sphere. Okay, means what? The density of the positively charged was not decreasing with respect to the space and time. Okay, what does he want to tell? Yeah, he was trying to say that the density of this positive charge was not variable; it was constant through the, or with respect to the space and time, it was not changing. Okay, as it was not changing means it was a constant, and and throughout the time, all the time it was same. Okay, so uh, we are trying to say that positively charged cloud was not changing, it was uniformly distributed inside the sphere. Okay, next, uh, these plums, you can also call it as a seed, doesn't matter. And again, what is there which he want to explain, or which he considered in his model, that this atom was neutral. Neutral means what? Neutral means number of proton and number of electrons. When the number of proton is equal to number of neutron. Okay. When we use this equal to sign, what does it denote? It denotes that RHS and LHS are equal. Okay. And again, one more type, uh, or the one more view, you can explain this equal to sign as a balance. Okay. This equal to sign gives us the information of balance. Okay. When I say that the number of protons are equal to the number of neutron, means what? Means what? The atom is balanced. Okay. And if the number of proton or neutron is increases, whether it is increase or decrease, whatever the case is there, in that case we will use the word unbalanced. Okay. This unbalance is going to cause some changes in the atom. What are those changes? And we are going to observe it further in the chapter. But here, okay, here we are going to study that this unbalance, or you may also use the word as a perturb. Further, you are going to learn the perturbation theory also. Okay, perturbation is nothing but the disturbance. Disturbance caused in an atom um, due to the imbalance between the number of proton and the neutron. Okay, so when the number of proton or neutron are changed, or the atom is in unbalanced state, what happens then? We must know what it is. So electrons in the atoms are going to oscillate about their equilibrium position. So what happens in the unbalanced state? Electrons are going to oscillate. Okay, they are going to oscillate around the equilibrium position. Now, as they are going to oscillate around the equilibrium position, again there will be some changes in the atom. What are those changes? What is going to happen there? There, okay, and so because of this oscillation, what is going to happen there? Their emission of radiation of definite frequencies, emission of radiation. So the result of this oscillation is nothing but the emission of radiation of definite frequency. Means whatever the radiation is there, those frequency are defined. Means those frequency are definable. That is not indefinite. We can't say that what sort of frequency were there. We were not knowing. No, they were having the typical frequency, and they were named as, or according to the frequency, we categorize the radiation, and we have named those radiation as infrared. I am writing here in the short: infrared, then ultraviolet, and visible. Okay, so what we had studied? Yes, we were studying the Thomson's atomic model. In Thomson's atomic model, he tried to explain that the atom is nothing but the positively charged sphere. That there is a positively, you may use the word cloud also there, and the negatively charged particles were named, or they were analogous to the seeds or the plums in the plum pudding model, or the watermelon. Okay, and the radius of the atom was given in the order of 10 to the power minus 10 meter. Then further, we also named the model as a plum pudding model. Then we studied the concept of stability, such as stability or the neutral concept, there where the number of protons and the number of neutrons are equal. Then we called it as the atom is in a balanced state. When the atom is in the unbalanced state, in that case what happens? The electrons oscillate around the equilibrium position, and due to this oscillation, the result of this oscillation is nothing but the emission of the radiation of definite frequency, and those frequency were related to the infrared, ultraviolet and visible light. Okay. Now, what is the failure of this atomic model? There are the two failures of this Thomson's atomic model. What are those? Yes, first thing, that it could not explain the origin of the spectral lines in the hydrogen atom. Okay, so what is the first drawback? First drawback, origin of spectral lines in H. Not explained. Okay, this is not explained here. Means in his model, he didn't explain the origin of the spectral line. This was the drawback. And the next drawback was the scattering of alpha particles. Through the large angles. This alpha particles scattering was studied, but through the large angle it was not studied. So this was the Thomson's atomic model and the respective drawbacks of the Thomson model.